Hi everyone, I'm Will Cooper from the MSP430 product marketing team at Texas Instruments. Today I'll cover the clocking and core modules section of the MSP430FR4x and MSP430FR2x microcontroller overview workshop. This video will give you a quick overview of the critical pieces of our microcontrollers such as CPU, the clocking systems, and even power management systems. The MSP430FR4x and MSP430FR2x are both based on an orthogonal CPU. This is very similar to the MSP430F5x and MSP430FR59 and FR69 that released earlier this year. A couple key things to remember is that it is an efficient, ultra-low power CPU. In addition, it's C compiler friendly with clear and easy to understand instructions in addressing modes. Plus, migration is simple since it's similar to other MSP430 devices. It also features atomic addressing for memory-to-memory instructions, and several instructions have been optimized. Now let's take a look at the operating modes for this device. You'll notice it's similar to other MSP430 devices in terms of its naming convention. These series of devices have multiple low power modes, with LPM 3.5 featuring under 1 microamp of current consumption, with the LCD controller and RTC enabled. Please note the other modes and their power consumption on the slide. These modes are enabled by a clock system on the FR4x and FR2x devices. The clock system has a couple of differences compared to some other MSP430 clock system modules. There are a few low-frequency clock sources, like the external crystal or VLO, and there are also a couple of different high-frequency sources, the DCO or digitally controlled oscillator, and the mod clock. The DCO has a frequency-locked loop or FLL that can use the REFO or XT1 as the reference. More info on this will be on the next slide. A clock can only be sourced from low-frequency sources. SM clock and M clock can be sourced from any clock source. Note that SM clock and M clock are always sourced from the same clock, but SM clock can be further divided down and it can stay on even when M clock is off. The SM clock frequency must always be the same or lower frequency than M clock, and any dividers on M clock will carry through to SM clock, though SM clock can then be additionally divided down on top of that. The clock system on this device is somewhere between the MSP430FR5969 DCO, which has preset frequencies, and the F5X DCO plus FLL that can be set to any frequency. Basically, the DCO can be set to specific ranges centered around particular frequencies, but the FLL will help tune the frequency within that frequency range. The ranges are smaller than the ranges on the F5X DCO, but they still have the 512 DCO steps within the ranges, so they are much smaller steps. This gives an accurate frequency even when just REFO and no external crystal is used. You can get plus or minus 2% over temperature. With the crystal, this is even more accurate at plus or minus 0.5% over temperature. There is much less jitter as well because the steps between the frequencies are smaller. The FLL also allows compensation for temperature drift because it is constantly adjusting and tuning the frequency based on the reference. Here is a visual comparison of the F5X DCO and the FR4X DCO. The D-core select bits set the frequency range. As you can see, on the F5X DCO, the DCO frequency ranges overlap, which allows you to set the DCO on any frequency. On the FR4X, the ranges do not overlap. They are narrower and centered around specific common frequencies instead. The DCO X bits set the frequency setting within the frequency range. The FLL can modify these bits to adjust the frequency according to the reference frequency. On FR4X, because of the smaller ranges, these frequency steps between different DCO X bits is much smaller. This helps you to be able to have higher accuracy. The modulation will also have less jitter as the DCO modulates two frequencies because the two frequency steps are closer together. In summary, the F5X DCO is a bit more flexible in that you can set it to any frequency. However, even though you have to select a more specific frequency range with the FR4X and can't set to a frequency in the gaps between the ranges, you get a more accurate result even without a crystal. and there's much less jitter because the two frequencies used for the modulation are closer together. Now let's talk about power management. The power management module on this device is similar to the FR5969 with a couple of differences. The PMM has a single supply line for both digital and analog modules. There is a built-in supply voltage supervisor that will cause the device to reset at a preset threshold. There is also brownout reset circuitry similar to other MSP430s. Lastly, there's an integrated LDO for generating the core voltage. You can run at any frequency all the way to 1.8 volts, and there's no configuration of different core voltage levels. There's also no external capacitor needed, saving cost and board space. The PMM also houses the internal reference voltages. The reference is automatically turned on or off based on your operating mode. The internal reference can be used to generate 1.5 volts for internal reference, such as with an ADC, or it can output 1.2 volts externally on a pin for external use. There are also bits to indicate the reference status so that you can tell if it is ready to use, and you can manually enable or disable the reference. The supply voltage supervisor module can be used to monitor your system. On the FR4x and FR2x microcontrollers, this module has been highly simplified. It uses a fixed threshold to help ensure the MSP430 powers on safely. This module can be used in all power modes, but can be disabled in LPM 3, 3.5, and 4.5 for minimized power consumption. Now let's move on from power management to the embedded FRAM. This FRAM controller is similar to what you might find on the MSP430FR59 microcontrollers. The FR4x and FR2x devices can run up to 16 MHz, but FRAM accesses are limited to 8 MHz. Because of this, wait states are needed if you run it greater than 8 MHz. You can set this up once at the beginning of your program with the line of code shown on the slide to configure your wait states. In addition, the FRAM has a cache mechanism. This helps to avoid a performance hit from the FRAM accesses. By fetching a few instructions at a time in the cache, anytime you have a cache hit, you won't incur the wait state penalty. We estimate that most typical code averages about a 66 to 75% cache hit ratio. So this means you would only see the wait state penalty 1 in every 4 cycles, which mitigates any penalty in your performance for wait states. Because FRAM is so easy to write to, just like RAM, it's important to be able to protect it from an errant write that could occur from, for example, writing off the end of an array or misuse of a pointer. Because of this, it's important to protect your code that is in FRAM from getting overwritten accidentally during runtime. On the MSP430FR4x and MSP430FR2x series, this is handled with just a couple of bits in the sys configuration module. There is one bit for protecting the main area of FRAM, and another bit for separately protecting info memory. When the bits are set, the area is protected. The protection is enabled by default at startup, so before trying to write to the FRAM, you must clear this bit, and then you should set it again when you're done to protect against accidental writes. I will leave you with this one last hint in this selection. If you are migrating from another MSP430 device, the sysconfig registers should be noted. These are a new feature of this device. These registers are used to configure device-specific settings. This includes FRAM write protection, IR modulation, ADC analog pin selection, and LCD power pin selection. Thank you all for watching this section of the MSP430FR2x and MSP430FR4x workshop. Check out the third section in the series to learn more about the key peripherals that stand out on these devices, including a new flexible and low power LCD module and IR modulation logic.